Part 4, using inverses to solve systems of equations. A matrix equation. We can write a system of equations as the matrix equation AX equals B, where A is the coefficient matrix, B is the constant matrix, and X is the variable matrix. So let's try that with this system of equations. So A is the coefficient matrix. So we use the coefficients of the X's and the Y's. Then we multiply by the variable matrix equals the constant matrix, which is the numbers on the right side of the equal signs. That would be our matrix equation that corresponds to this system of equations. Now, to use a matrix equation to solve a system of equations, we can solve like this. If I have AX equals B, and I multiply both sides by the inverse of A, then on the left side, where we have A inverse times A, that is the identity matrix. So we have the identity matrix times X equals A inverse times B, and the identity matrix times X is just X. So to solve a system of equations using a matrix equation, my solution would be the inverse times the constant matrix. So the inverse of the coefficient matrix times the constant matrix should give me my solution. Let's try that with this one right here. So we found earlier the inverse of this coefficient matrix. So I'm going to rewrite my matrix equation. Okay, now we know that if we multiply both sides by the inverse, which is this right here, then the left side, we just have the variable, and the right side we have that inverse matrix, the inverse of the coefficient matrix, times this constant matrix. So if I multiply through here, first row, first column, 3 times 3 plus negative 5 times negative 4 is 9 plus 20, which is 29. And the second row, first column, negative 3 plus negative 8 is negative 11. So the solution to this system of equations is 29, negative 11. And if we already have the inverse, this goes really quickly. Let's try the same thing with this 3 by 3 system of equations. So we already found the inverse of this one also. So to find the solution, remember my equation would look like AX equals B. And when I solve, I get X equals A inverse B. So for this case, X, our variable matrix, XYZ, equals the inverse times the constant matrix, which is 2, 7, negative 4. Those numbers to the right of the equal sign. And then when I multiply, notice this is a 3 by 3 matrix. This is a 3 by 1 matrix. So my new matrix will be a 3 by 1, and I'll have the solution in this new matrix. So I'm going to multiply rows by columns. So first row, first column, 3 times 2 plus 3 times 7 plus negative 1 times negative 4 gives us 31. Second row, first column, negative 2 times 2 plus negative 2 times 7 plus 1 times negative 4 is negative 22. And third row, first column, negative 4 times 2, negative 5 times 7 plus 2 times negative 4 is negative 51. So the solution to this system of equations is 31, negative 22, negative 51.